Good morning, everyone. Great to have you at our second session, at least my second session of the morning. Hope you had a first great session, whatever you chose to attend this morning. I chose something that was really interesting around Netflix and how a Finnish company is kicking Netflix out and taking over user subscription, which is pretty interesting. On today's call, I get the privilege of introducing Dillon. Dillon's going to be speaking about productizing deep learning modules at scale, which certainly another equal passion of mine. How do we take machine learning AI and actually make it robustable into sort of operating models for large enterprises? So really taking AI and ML and bringing it into the mainstream and delivering great experiences is what I'm hoping to kind of learn today. Dillon is from Paperspace. It's a 5-year-old cloud and machine learning infrastructure company. They're backed by Y Combinator, Battery Ventures, Sinwire Capital, and Intel Capital as well. He's a graduate research assistant of the University of Michigan. He's also a Y Combinator grad and has a BA in philosophy at Northern Carolina, which is really, really interesting. I kind of did a little bit of digging, found some interesting quotes that I thought really resonated on what we're going to talk to you about today. Dillon has been quoted as saying, "I truly believe a successful business is one that focuses on the end users, not on a quick exit strategy or other secondary considerations. Great longitude and infinite game thinking on how to do a startup." Another quote, "Technology is largely about the people and their ability to communicate and band together to solve a complex problem." I think that's just dead bang on, more important today than ever. Another quote, "Don't think you can overestimate the value of taking a step back from your work, as time away helps give perspective and build insights that you wouldn't get otherwise." I think that's even more important in our COVID world, stepping away from our desk, going for a walk. Really love these quotes. And then final one, "Someone who expresses too much confidence and rigidness in their approach is a red flag." Really just thought those were great quotes that Dillon has sped over the years when talking about how he brings deep learning models at scale. I'm sure will be relevant. So Dillon, over to you, buddy. Really looking forward to what you have to teach us today. Thank you so much.
Awesome. Thank you, Stuart. Yeah, interesting quotes. We'll see how I can tie them all together in one kind of fail swoop here. So today's talk it's a little bit different. It's going to be a little bit more of a discussion. And I'm going to talk about just a few concepts that have been top of mind for us here at Paperspace for a while as we think about really the integration of machine learning into traditional sort of application development. So I will just kind of kick it off. The high-level format here, I'm going to go through introduce some concepts to sort of our discussion, talk about what we're building here at Paperspace and how those relate, and then kind of open it up because I think there's a really good discussion to be had here. So it will be somewhat technical, but I think kind of the high level we can, I think a lot of folks should be able to see some value here. So really quickly, I'm calling in from Brooklyn here. We are, like Stuart mentioned, about 5 years old. We are a cloud computing company. And this is important because we don't identify as a machine learning company largely, although machine learning is really what we do all day, every day. We are, obviously, because of COVID, kind of spread out around the world. And just fun fact, Paperspace is an old term in building architecture that refers to a 2D projection of a 3D model. So let me just kind of kick this off. So this is a contention that we have kind of introduced. I think it is somewhat controversial, but the general idea here is that machine learning, especially over the last few years, is really becoming a native tool in a software engineer's tool belt. And so we're going to dive into this a bit. And the idea is that this kind of motivates our approach to developing software for machine learning engineers and data scientists, as well as how we think about the proliferation of machine learning as sort of a general capability within organizations. So the other kind of key point here is, I think one of the challenges is that as machine learning has become more common, we've seen this kind of requirement for retooling. And so we've been thinking a lot about how can machine learning become a native capability within an organization without that type of retooling. So just a brief history here of sort of the folks in our space and people working on tooling for machine learning engineers and data scientists. If you kind of think back to early deep learning models coming out of Toronto and Waterloo, primarily built on sort of early GPUs, bare metal systems. The last few years have seen a real acceleration of those types of sort of the advancement of these platforms. And so where we find ourselves today is we've gone from bare metal kind of GPUs under your desk to running things in the cloud and virtual machines to sort of managed services like managed Jupyter Notebook services. And where we are today is the emergence of what has largely been called the MLOps platform, which is basically lifecycle management, end-to-end workflows, and the ability to kind of interact with machine learning at a much higher level, kind of syntax and semantics. So real quick, if you look at sort of data flows at any organization, and they really, if you zoom out, kind of look the same. You have data coming in, there's this kind of meaty part of developing a model, and then ultimately you want to train it. And we're going to zoom into this a little bit, and I want to introduce just some ideas that we've had on how to think about this problem. Some challenges today for anyone getting started in quote unquote production machine learning. Obviously, best practices still emerging. Being able to go from R&D into production is still a challenge, especially as that requires integrating with larger software teams. And then also we have a whole lot of new hardware because foundational to machine learning is largely the accelerators that are coming to market and the ones that exist today. So GPUs, TPUs, IPUs, all sorts of ASICs, hardware devices. The most common machine learning accelerator today is by far and away the Core ML accelerators in iOS devices. So how do we think about those kind of holistically? So if we zoom out a bit, one of the practices that we think is really helpful to motivate this is the idea of CI/CD. And so for those folks who are familiar with developing traditional software applications, CI/CD is a set of practices that means you basically continuously integrate or test and continuously deploy your application. And so if you look at sort of traditional architectures or web applications, I'm going to use this to kind of disambiguate where we see the challenges with machine learning today. It's pretty simple. It's kind of unidirectional. You have a single input, which is your code, coming from GitHub or GitLab. It runs, it builds a container, it tests it and deploys it. And obviously there are a whole host of tools for doing this. Jenkins, Circle CI, Travis, a whole host of tools here, and some interesting things to call out. I mean, one, largely we make assumptions about sort of what the hardware that is running these containers. I mean, they are portable in the sense that they largely run on x86, they run in Docker. And it's also a relatively simple flow. So if we look now, and this is, we can kind of go back and forth on sort of what the primary differences are between sort of the machine learning process and a traditional software application process. We see a few things. So the most obvious here is two main inputs. So you have code and data as kind of primary inputs into the system. The second one is the kind of the differentiation between sort of different hardware architectures. So your container could run on a CPU for a data processing step, train on a GPU, and then deploy to a Core ML device. So you have these kind of big differences. Training can take a lot of time, so you want sort of built-in primitives for early termination and thinking through what sort of validation looks like at each step. And ultimately, the kind of holy grail here that everyone's trying to get to is the idea that this is not a unidirectional pipeline, but rather it is sort of continuous. How can we create real-time online predictive engines that are intelligent and continue to kind of update themselves? So this is sort of how we think about this problem. And if you dive in even more, we've seen the emergence of some really interesting steps, even at the very tail end of that process. So if we assume sort of you have code coming in from source control, you have data coming in from a labeling tool, or maybe it's in an S3 bucket. But actually within the process of building and deploying a model, there are lots of different steps. We've seen the introduction of quantization, compilation, the idea that you can have multiple deployment targets. So you could deploy a model to if you're Adobe, maybe deploying a model to a Photoshop user on a Mac device, or you could be deploying that to an iPad, say, or a Huawei device. And so this kind of step of the pipeline is beginning to become much more complex and interesting. So I'm going to talk a bit about sort of just at a very high level the software we're building. So the company is called Paperspace, and our main product is called Gradient. And Gradient is our MLOps tool. And the idea here is, can we consolidate a lot of these best practices and allow people to train, deploy, and collaborate on machine learning models? Ultimately, this is with an eye towards taking something from the ideation phase or the R&D phase and moving that into deployment. So I'm not going to go super deep into our particular stack, but I will talk about some of the assumptions here. And largely, we've seen a lot of different tools in the MLOps space, and we are taking a fundamentally different approach, largely driven, I would say, by this perspective that machine learning is a software engineering practice. So what that means is, it's not building machine learning tools for machine learning engineers. It's building tools that allow any software engineer to integrate the power of, say, TensorFlow or PyTorch or a predictive model that's coming out and applying that into an existing kind of process or pipeline. So the benefits of this kind of CI/CD approach, oftentimes sort of grouped in with the idea of an agile methodology, is that you kind of take these core concepts of being portable, reproducible, and safe. Safe oftentimes means you know what artifact is being deployed into production, and you can trace its origin and provenance. And these kind of concepts largely motivate our perspective here. So, when I dive in a bit to sort of the platform itself and sort of the assumptions, I want to call out an important piece here. So, we are built very much on top of Kubernetes. So for those who are familiar with sort of the modern kind of DevOps or application space, especially for web applications, Kubernetes has become sort of the de facto standard for containerized orchestration. So what this allows us to do is basically take sort of existing workflows, map them into a container-based approach. And this means that folks can basically bring any tool they already have or process and begin to integrate that into a deterministic pipeline. For folks that have maybe used Kubeflow or other kind of tools in this space, it's important to note that we've done everything from our runtime engine to sort of the container orchestration and the pipeline steps are all driven by a tool called Argo, which is also what powers Kubeflow. And so the point here is that we are thinking about this largely from a software engineering practice, and the idea of the machine learning pieces are very much scoped into kind of the deterministic kind of containerized approach. So there's an interesting concept that I just want to introduce because it's been very much a discussion within the software engineering space, which is this idea of the inner loop of development. So in the software engineering kind of web app space, what's largely happened is you have these very complex Kubernetes installations of your production application. And the idea is how can you test things locally and deploy to production, or promote something from a dev staging environment into a production environment. The interesting thing about the machine learning space is that these environments are often very heterogeneous, from a hardware accelerator approach to a where they live and the cloud resources that are available. So our approach has been very much you should be able to install Gradient, what we call a processing site, anywhere, and begin to embed best practices. So dev staging production environments, taking a model that you might train locally and deploying into a cloud hyperscaler, or taking a data set that has been created in one cloud and move it to another. And so this is really essential to what this kind of emerging concept of the inner loop of development, because in many cases the machine learning parallel is you don't train your model on the full data set until you have some conviction around it, in which case you might promote it to a larger cloud or more resources. So when I dive in a bit to just Gradient itself, and I call this out more so to just talk about sort of the approach, a MLOps stack is really responsible for a number of things. It's responsible for orchestrating compute, the runtimes, which include CUDA or all sorts of other sort of basically layers in between the container and the hardware host itself. There are different hardware accelerators. So there's the GPU model, which is a PCI device that fits into a server, and then you have sort of the network model, which is like a TPU, or we've seen a few other accelerators emerge with a similar approach. And the idea here is that an MLOps kind of platform should do a lot of the underlying pieces, from job scheduling to artifact management, auto scaling, spot instances, et cetera, and allow engineers to focus on the top kind of the thing that's going to drive the most business impact. And this is true for software engineering as well. When we deploy our web application, we use Circle CI, and it's part of a process where any engineer coming in doesn't have to think about sort of the hardware it's running on, but that part has largely been abstracted away. So this is going, I'm not going to go into a ton of details because I do want to open this up for more of a discussion. But our approach to kind of drive this movement towards machine learning as a software engineering practice has been to take things, for example, like deterministic config files that you see very much in traditional CI/CD practices, and move that into the machine learning context. So today, Gradient has very tight integrations with source control management, and it allows you to do things like provide a very rich set of syntax and semantics for, say, regression testing, or for example, being able to map a pull request on a repo into a notion of what sort of metrics or aggregation steps that you want to actually kind of measure. So this is largely just to open up a conversation, because I think that we are doing this in production today for basically every vertical. We have been building out these tools. To date, we have roughly 400,000 people that have signed up for Paperspace and Gradient. We have a community that we're trying to build around this, and as we do that, the idea is to kind of consolidate these best practices. We think that the CI/CD approach is actually the right one here, and so as that happens, we have to begin to update, I think, our language. So when you think about sort of the triggers to a traditional kind of code application pipeline, you can think of things like a git commit as a notion of code drift. And when you start thinking about how these concepts map, then you start saying, okay, well, a native trigger to this pipeline would be, some notion of a data shifting as an underlying piece to the model. The outputs are a little bit different. There's artifact management, there are kind of web service deployments, and then of course you have multiple targets as well. So we kind of breeze through a lot of this, and the goal is really to kick off a conversation. For folks that are kind of interested in this methodology, I recently was on a podcast called This Week in Machine Learning, where we go much deeper into it. But largely, what we're interested in doing here is how can we create tools that more closely resemble traditional software engineering tools? And I think what's at stake here is, for every 100 deep learning engineers you probably have 10,000 traditional software engineers. TensorFlow, PyTorch, the whole host of models that come out every year, especially at conferences like this. These are in the early stages of sort of their mass proliferation, but largely the tooling needs to consolidate. So the language around, for example, an inference deployment in the cloud, can we map that to a notion of a build, or the primary artifact of a system in a say an iOS app would be the iOS executable. In our case, it's a model. Can we rethink source control to integrate data, so you have a much richer set of semantics and syntax for data flow? And then there's the whole question of how do you begin to think about things like experimentation and mapping that to a Git native or source control native process. So thinking of, is a hyperparameter sweep a single Git commit? Is it a branch, or is there some analogy where this doesn't actually map one-to-one? So I know I kind of breezed through this. I would encourage folks to reach out if you're thinking about this. Gradient is available for anyone to sign up for. You can go to gradient.paperspace.com and you can actually begin using these tools. With a free account on our platform. So I'd encourage folks to continue this conversation. I think that this is going to very much allow the acceleration of being able to adopt machine learning technology. And I think that what's at stake here is really the introduction of a whole new software paradigm to a class of application development that is much better understood. Or will be much better understood in the coming years than it has been in the last few years. So I think I'm running out of time, but thank you very much. Obviously, very excited for questions, and hopefully we kickstart a kind of dialogue around this.
Great, Dillon. Thank you so much. We do have two questions that came in, and actually one of our attendees I may have answered the question already, which is the first time I've seen it, but I'm still going to ask it just to get your view. So the first question is, what's the difference between taking this route of productization versus product-ready tools like Amazon, SageMaker, or Google Cloud AI?
Yeah, so what I would say first is, people should invest in a tool like a SageMaker or a Gradient. We think that our approach is a bit different than a few of those other folks. I think the closest analogy is probably Kubeflow itself. I mean, the big difference for us is that we are a fully managed platform, so you don't have to actually do a full Kubernetes installation. We also work natively across all different clouds. But yeah, I mean, the emergence of these MLOps platforms is really a signal that the sophistication of, or the desired kind of output of a machine learning system is no longer just a model that lives in a GitHub repo that is not tied into a larger system, but is actually part of a broader kind of application development process. So in the ecosystem there are there's MLflow, Kubeflow. SageMaker is maybe a bit higher level in terms of the semantics, but the approach is the same, I think, largely, which is that you need a tool like this to begin to integrate complex topologies into existing paradigms that are better understood not just by academics and researchers, but by the folks that are the SREs that are responsible for maintaining something in production.
Okay, great. Yeah, thank you. Anyone, you can post more questions or any follow-up questions in the chat. I've also posted a few links, including Dillon's LinkedIn profile, his Paperspace connection, the Gradient Connect thing, as well as the podcast. So look in the session, everyone, to collect those before we close down the chat. Next question, Dillon, will Gradient CI be open source?
Yeah, so we are hopeful that will happen, and it's largely just a time thing. So we've started to open source a lot of components. For example, the full Gradient installer is actually an open Terraform installer that's available on GitHub. Our SDK and CLI are fully open, and so yes, I think that we are moving towards opening up more components. Largely, it's just we are a small engineering team. But yeah, I mean, I think that we are also of the opinion that there will be no single ML platform to end all ML platforms, and actually there will be lots of different tools that are part of this process. We use probably 30 different tools to develop our web app that we deliver to customers continuously. Really, the best way to think of Gradient, I would say, is as a scaffolding that allows you to kind of scale things up in the right way based on these sort of best practices.
Okay. Follow-up question to your first question around the very first question. They're asking, is there going to be a cost difference between the two approaches?
The two approaches being?
So we originally asked, what's the difference between taking this route of productization versus using production-ready tools like Amazon? The follow-up question to that, which you already answered, was there a cost difference between the two? I would assume yes.
Yeah, I mean, I think so. Cost is an interesting one. I think that we are largely, as an industry, thinking about it in the wrong way. And by that I mean, we focus a lot on the per second compute cost of GPUs because they're really expensive. They take a lot of energy. They're expensive. Until recently they were relatively hard to come by. I think what's at stake here is actually something that is much bigger. And when we talk to companies, they are not so much worried about the actual compute cost. It certainly is a factor. But what's at stake here is the ability to actually take something and move it into production and drive real business value. And so if you can accelerate that process from taking months, whether it's largely about quantity over quality. If you can iterate very quickly and you have a tool, kind of a framework for iterating quickly on models and getting those into production into an existing system, you're going to derive a lot more value from the machine learning efforts that you're investing in. Because in many cases, it's not the sunk cost of the GPUs that you're worried about if you're a large organization. It's the idea that you have a lot of smart people working in a system that isn't quite mapped to the existing kind of application or software engineering practice.
Great, thank you. Net new question here. Oh, sorry, one of the questions has actually been, will the presentations be shared? My understanding, and please someone keep me honest, they're going to be shared after the event should the author allow that. But as said, I've also posted Dillon's LinkedIn profile. Hope that was okay, Dillon. I figured they could have found it on their own anyway. So I'm sure you could reach out to Dillon to speak directly as well. One more question here we've got. I found that ML scientists in similar roles often require 2 to 3 times relative amount of engineering support for productionizing productionizing and maintaining ML capabilities. Have you found that commitment to ML ops and tooling changes this ratio in practice? So
absolutely, and this goes directly to the cost question. So if you think about the cost there, I think that's pretty standard, 2 to 3x, the relative amount of engineering effort. Largely you see these handoffs of everything from a DevOps team rewriting a model in some system that they better understand to a clunky handoff that is not in version control. So really what's at stake here from a cost perspective is if you provide a scaffolding or a tool that allows the ML kind of development to happen in the existing system, then you eliminate that overhead. And in our case, because, for example, everything is sort of within an existing Kubernetes installation, the DevOps team can introduce whatever tooling they're already using, from an OAuth gateway in front of their deployments to a Prometheus collector that they want to add to an existing node. So absolutely, and that is really what's at stake here. How do you make the relative cost of investing in a machine learning process or developing a model which can drive business value less costly? And that is mostly an engineering time cost when you're moving out of academia into a business environment, because the support costs are substantial. Engineers are expensive. Time is a huge opportunity cost. And you don't want to reinvent the wheel. So I would encourage everyone to invest in a ML ops platform, and obviously biased, but I think that our approach is one that will scale as this becomes a better understood and better integrated technology.
Great. We've got one last question that came in under the wire. Could you please suggest a learning path for getting up to speed with ML ops, especially with a focus on the ties with software engineering?
Yeah, I mean, so that is a fast-moving space. I would say that what we've seen are that people who are really successful are folks that are coming either from a software with some software understanding and applying that to the machine learning world. Obviously, it depends on where you are in that stack. But we are in a renaissance right now of kind of cloud application tooling, largely driven by the containerized Kubernetes approach. A lot of that is impacting the machine learning space by proxy. So I think if you're just starting, I think something like FastAI, we've worked with Jeremy Howard at FastAI to kind of onboard folks. But as you get more advanced, I think a lot of the learnings are still coming from what would nominally be called sort of software engineering as opposed to machine learning or data engineering.
Great. All right, I'll look to the chat for any final questions. Don't worry about typos to squeeze it in. I'm not seeing any more. So with that, Dillon, I'm going to say thank you so much for a great informative session. I'll be honest, some of it was a little above my head, but I'm not nearly as smart as you. But really excited for what you're up to. We'll visit you in New York when I'm next down there, or come on up to Toronto sometime. Thank you, everyone who joined us. And please, Dillon, maybe we'll see you in some of the other chats. Thank you so much.
Awesome. Thanks, guys.